This is a test on a portable RCD. It is a 30 milliamp leakage current device. RCD, residual current device. So to carry out this test, I'm using the Megger multifunction tester. It's model 1825. And I'm going to use the auto function, and then we'll play back the results and see how this RCD stands up to the requirements. So I've got the auto selection here. I've got it selected here for 30 milliamps RCD, and I'm going to press the test button. And I have to reset it each time. So it's completed its auto test, and this is the instruction we get telling us that it's ended. So now I'm going to recall each of the results. So the first result is down here at half times the leakage current sensitivity, which will be at 15 milliamps. It is timed out at greater than 1999 milliseconds on 0 degrees of the cycle for its commencement of the test. Now on this particular instrument, on the auto function, it doesn't do a 180 degree test on the half sensitivity setting. So the next test that comes up will be at ×1. So this one here is at ×1. There's the one down there in the corner. By the way, this instrument is very nice in that it does the AC and pulsating DC tests in one go. You don't have to do it twice. It does the type A RCD, which is a AC and pulsating DC device. It does it all at once. So the tripping time for this here on the ×1 setting, that's at a 30 milliamp leakage on the 0 degrees, is 18.4 milliseconds, which is well within the 300 milliseconds that we have to operate at within that time. On the ×1 setting at 180 degree position, it is tripped out at 28.8 milliseconds, which is also well within the 300 millisecond requirement, and that 28.8 is the value that we'd record because that is the higher of the two values. Now this then went to the 2 times position. Now that's not required. In New Zealand we only have to go half, 1 and 5 times, but it does have the facility here to do 2 times. So on the auto it does each position. So on the 2 times at 0 degrees was 15.9 milliseconds. 2 times at 180 degrees was 10.3 milliseconds. This one here is the one we're concerned about. This is the 5 times the current at 0 degrees, 14 milliseconds, well within the 40 milliseconds that we are required to operate within. At 180 milliseconds on ×5, it tripped out at 10.3 milliseconds. So that was well within the specifications. And then it just goes back to the beginning, which was the 0 degrees on the half the leakage current, which would be 15 milliamps. So I've reset the RCD, and we'll go now to the ramp position, and we'll test for the leakage current and see what current that it actually trips out at. So press the test button. So it tripped out at 24 milliamps at 0 degrees. Reset it. and move on to the 180-degree position and press the test button again. 24 milliamps again. So 24 milliamps is pretty fair. It's a 30 milliamp rated leakage current RCD. It's well over the nuisance tripping value of 15 and not too far off the 30 milliamp of its actual rated leakage current. I think 24 milliamps is pretty fair for this device, and I would give it a tick of compliance. That this portable RCD here is perfectly good for use. This is one here is a little bit different from the earlier one. This one here actually has a lead with it that then has a socket. So this is quite handy for outdoor use, where you plug in the RCD and then run your lead out for maybe working outside with some portable electrical appliance. So the Megger MFT 1825, it's a nice instrument. Has other features, of course. It'll do resistance measurement, it'll do insulation resistance, it'll do earth loop impedance testing, as well as other values of RCD testing also. And a bit more expensive than, for example, the Uni-T instrument that I was using in an earlier video. These here tend to sell for around about 2,000 New Zealand dollars. So thank you very much for viewing, and I hope this has given you a little insight into how we'd go about testing a portable RCD. And of course we can use the trip button as well. Catch you in the next one.